welcome to those who are joining on Zoom. We're just getting us up on YouTube now as well, so welcome to those who are joining on YouTube. We have an awesome talk today. Feel free to introduce yourselves in the Zoom chat. If you are in Zoom, let me just, here we go. As always, make sure, or if you want to, please introduce yourself and where you're from in the Zoom chat. And a reminder that if you're introducing yourself, when you do so, make sure that the little bar that says panelists and attendees, make sure it says that instead of just panelists, because then you will be talking to all of us and not just Chris and I. It's great to see everybody. I'm sorry that PEI is cold. It was warm here last week, and then it dropped again, so it's a little bit chilly again.
It's into the the sap running season. Cold at night, warmer in the daytime.
It's time for maple syrup, which I'm always pro. Excuse me. So today we are going to be covering a great topic. We're going to be talking about astronomy and religions, and the reason we chose this timing. Hold on. The reason we chose this timing is because we are 4 days away from the vernal equinox, which is the point at which our night and our day are the same length, or the sun is directly over the equator, which is very exciting. And it's also very important in many different religions. And so on that note, I am going to turn it over to Chris, because Chris holds almost all of the knowledge on this topic, and I hold almost none of it.
Well, as I stated when we did our horoscope, our astrology session, I'm by no means a scholar when it comes to world religions and things like that. But I do tend to, when I see a festival or an event or something coming up on the calendar, I do then wonder, I wonder if there's an astronomical link to that or connection with that. And so I've been incorporating those into my Skylights blogs, my weekly Skylights blogs. And only once did I ever have anybody question me for doing that. But I replied and said where I was coming from. It wasn't there to promote any given religion per se. I was just highlighting it just happens that this month, this particular group is celebrating, and it's because of a link to astronomy. So I went back into the archives, the dusty annals, and I pulled out or extracted a number of those examples for today's session. And I haven't got it in a perfectly clean order of events, but we'll run through it, and we'll make sure that everybody figures out what we're trying to share with them. But really, it all comes down to clocks and calendars. I mean, since time immemorial, people have been keeping track of the year and the passage of time using the Earth and Sun relationship. Now, I've got the moon behind me here, wrong side. That'll come into the picture a little bit later. But we early on worked out that the sun rotates, or the Earth revolves or rotates on its axis, and that defines one day. And we actually decided that would be 24 hours. That's not something that nature gave us. That's what humans decided at some point in time, that we would divide that rotation period into 24 equal hours and subdivide that into minutes and seconds. But then when it came to linking that to the length of the year, people, by observing the skies, were able to tally up. Eventually, I'm sure people were notching on pieces of wood or carving on pieces of rock back in the long ago time, worked out that the cycles of the sky was repeating every 365 days, asterisk. So it's actually 365.2425 days is the length of a year. And you can see immediately that one day does not divide evenly into that period of time. So that resulted in this mismatch of extra fraction of a day cropping up in our calendar. Now, as I said, we'll talk about the moon a little bit later, but the moon repeats its visible cycle. And the moon is cool because it's something that everybody can see and recognize the phase of the moon. Unlike the way that the seasons turn over, it's not always immediately obvious to you especially if you lived in a temperate area where you didn't get a severe winter, severe summer. It was just sort of nicely the same all year round. You might not really even know that the seasons were flipping over. But the moon, you can. So the moon repeats its phases every 29.53 days. We call that a lunation. And again, that's nature gave us that amount. So the only thing that we got to choose was the day, the length of the day, the 24-hour period that we work from. So the length of that 24 hours, that's called a solar day. That's the time between the sun is, and what we typically use is when the sun is culminates or highest in the southern sky at noon, what we call noon. And then 24 hours later, that the sun ends up in the same location again. So that's the definition of a day. That's a perfect way to count the days, because you can't use sunrise and sunset because they vary in time throughout the year. And at midnight, there's no sun to look at. Everything else in the sky moves around over time. But the sun reliably ends up over the southern horizon at noon every 24 hours. Now, I'm lying a little bit because of the complexities of Earth's orbit and things like that. The length of the day actually varies by up to about 30 seconds at different times of the year. But that all works out in the wash, so we don't really worry about that in terms of our watches and our calendars and things like that. Yeah, I made some notes here. So let's see, it's 29.9 seconds longer around the December solstice, and the day is 13 seconds longer near the June solstice, 20 seconds shorter near the equinoxes. So the only time the day is exactly 24 hours are on the cross quarter days, which we'll get into in a minute.
Oh.
Yeah, that's cool. All right, so let's talk a little bit more about calendars. So we've got this spare half day or spare quarter day that we have to play with in our calendar. So by the time the Earth goes around the sun once in a year, we end up in a slightly different spot because of that quarter day difference. And people began to realize that pretty early on, but the person that we accredit with kind of dealing with it is Julius Caesar. So according to the history books, around 45 BC, Julius Caesar decreed that the calendar would become a standard 365 days long with an extra or an intercalary day. That's intercalary, intercalary day.
Intercalary, like not intercalary, like
not food calorie.
Yeah.
Inserted every 4 years. So they knew by then that it was drifting by a day every 4 years. Originally, that day that they put in had no particular date, but it was put into February. And then later we decided to tack it to the end of February to make it February 29. Now, the reason it's called a leap day is because if you look at the calendar, if you had a calendar that flips year to year to year, let's say you study your birthday and you check your birthday every year. Normally, it advances by 1 weekday every year. Mm-hmm. But in a leap year, it advances by 2 weekdays. So we leap over one of the weekdays. That's why it's a leap year. That's the expression. That's where the expression came from. Now, for people who one day set up the Mars colony, okay, the Martian day, or it's called a sol, is a little bit longer than an Earth day. But the relation between a Martian sol and Martian year, it's 668.5991 sols in a Martian year. And that means that they'll need 3 leap days every 5 years.
Oh, they have more math to do.
So they've got more math to do. Yeah, yeah.
On that note, there's already a question from Joe, which I think is kind of a neat one.
Sure.
Since we're talking about math, Joe asks, could we not change the length of a minute to get one trip around the sun in 360 days? And then we'd have 12 months with 30 days, except
no,
we can't.
The length of the day, the 24 hours, is completely arbitrary. It's just that the Earth rotates once on its axis in that block of time, and that's just not divisible into a year orbit.
A day, the definition of day being from that, like the sun goes to the same spot in the sky each time.
Noon to noon, yeah.
Because like technically, I mean, in theory, we could just make, you're right, we could change the minute and then the days would slide. The
days would drift, yeah. The hours of the day would drift, yes, right. Yeah. So I think this is better.
Yeah, because then you're going to have to, sleep randomly in the middle of the night in various spots. Randomly in the middle of the day. Sorry, we're astronomers.
So we're not quite done with dealing with the calendar. So Julius Caesar set this up, and we've been using it ever since as what we call the Julian calendar. It still didn't account for that 25 thousandths of a day. That the 0.2525, it dealt with the 0.25, but not the 0025 extra at the end of the day. So that still meant the calendar would drift by about 3 days every 400 years. Now, most of the time you wouldn't care, except that there were certain religious observances that happened that were linked to certain times of the year. And if they were tied to a calendar date, then over the centuries, they would move off their time of year that they were meant to be. And Easter is a main example of that. We'll come back to Easter in a little more detail in a little bit. But in around the year 325, there was something called the Council of Nicaea, and actually involved Christians. It involved the Hebrew scholars, and they were setting up, how the various movable feasts or that kind of thing would sit on the calendar. And then everything was set for a while, but then by the time we got to around 1580, 1582, Pope Gregory the 13th, they realized that the calendar was drifting off, and that, say, Easter was no longer happening in the nice, warm springtime weather. It was starting to happen off of that. So he decided to correct it and created the Gregorian calendar. And that's what we use, the Gregorian calendar. So if you use Stellarium, you'll see that there's an option to bring up the date and time. And then there's a tab for Julian. So Julian is kind of just a daily hours and minutes tick over. But what we're using is the Gregorian calendar, done by Pope Gregory. So he wanted to do two things. He wanted to fix the accumulated drift, and he also wanted to fine-tune the leap system so that it wouldn't continually drift off. So what he did is he decreed that Thursday, October 4th of 1582 would be followed by Friday, October 15th, 1582.
So they just lost a week?
So he corrected the 10 days that had accumulated since the time of Julius Caesar to put things back. The other thing that he did is that still left that drift that about 1 day every so often that hadn't quite been dealt with. So what he did is he also said that we have a leap day every 4 years, except if it's a century. If it's a century, then we don't bother having a leap day on the round centuries. But guess what? That still didn't quite fix it. So the exception is if the century is divisible by 4, then it's still a leap year.
So if you didn't like rules before, let's have a bunch more rules.
Yeah. Well, that's the only way you could make it all fit. So basically what that meant was that the year 2000, which was divisible by 4, should have been a leap year, but it wasn't, in order to keep us on track. To get rid of the final little bit of drift that really happens over millennium, Sir John Herschel, the astronomer, back in his day, he proposed that every year, 4,000, 8,000, 12,000, we would also not be a leap year, just to keep it in line. But I think we're pretty good.
I thought now we've gotten to like leap seconds occasionally as well, where clocks that are capable of, well, now that we have clocks that are capable of keeping such fine track of time, they do that.
So that's because the rotation of the Earth is changing in speed, and that's due to tides. So just as the Earth, long ago, the Earth stopped the moon from spinning and slowed it to the point where it keeps the same face towards us, the moon is also causing the Earth to slow its spinning. And eventually the two will end up locked face to face, just like Pluto and Charon. They're like a dual planet where they keep the same hemisphere towards each other. The math around that has to do with the mass of each object. So the moon being much less massive than the Earth, it happened already, and the Earth will take a while.
Yeah. There's a correction in the chat.
Did I get something wrong already?
It was just an order of 10 issue that it's the century year divisible by 400, not 4. And I think you explained that by going 4,000, 8,000, 12,000.
Yeah.
That's what folks are saying, I think.
It's a leap year every 4 years, unless it's a year ending in 00.
Yeah.
So that we skip those.
Yeah.
Right. But if it's a year ending, but if it's a multiple of 400, then we continue having one.
That's okay. There it is.
Yeah.
And then briefly as well, Julian mentioned for metric time, because the imperial time is not divisible by 10.
Yes, well, that's for another day.
It's
All
not
right,
religion, quite that one. That one's just time. Yeah.
let's finish up one more thing here. So you may have heard of, and my wife and I tease about this all the time, the Orthodox calendar. So we have Orthodox Christmas, Orthodox Easter happening long after the way most of us celebrate. And that's because the Eastern Orthodox religions opted not to adopt Pope Gregory's proposal. And so they've kept that 10-day drift, and that 10-day drift has now increased to about 13 days. I forget the exact amount. And because they're not making these corrections, then their calendar will also increasingly go out of sync, delay more and more over the centuries. So that's why the Orthodox religions celebrate their festivals delayed past the Western ones. All right, so that's some basics on the clock and how we keep the calendar straight on the year. The next thing, of course, is to do with the seasons, right? So we've got our 2 equinoxes and our 2 solstices, and as you said, we decided to pick today's Insider's Guide as our religious one because we're coming up on the March equinox. I like to call it, now many people call it the vernal equinox, vernal being the Latin word for spring, but of course that's a little bit limiting because it's not spring in the southern hemisphere, it's autumn starting in the southern hemisphere.
Yeah.
So March equinox is a little more accurate for talking about it. But yeah, you can call it the vernal equinox if you want to, but it's only relevant to the northern hemisphere. That's going to happen on Sunday. Now, what's happening there, and I can bring up Stellarium here and I can show everybody how this works. Let me just bring it up so we can demonstrate this. I'll bring up share my screen here. Here we go. Share that. So if I set Stellarium to say around local noon time. And by the way, we don't need to get into this, but there's real noon, local noon, that kind of thing. We can talk about that another time.
Mm-hmm.
So what I've got here in the sky is I've got the sun shining around the noon time. I've adjusted for daylight savings, so local noon is really happening around 1 o'clock. Then if I bring up the celestial equator, so the celestial equator divides the bowl of the sky into a northern half and a southern half. Of course, the northern half includes Polaris and the North Celestial Pole. Let me just bring that back. And during the course of the year, as the Earth orbits the sun appears to move through the stars. And what it does is it follows the path of the ecliptic. This is the diagonal line here, the sort of rose-colored line here. And it travels along the ecliptic by about a finger's width every day because it's got to do 365 degrees in 365 days. So it's about a degree's worth of motion every day. And when we come up onto the vernal equinox or the March equinox, what's happening at that point is that the sun on the equinox is on the equator. And as you said, the sun is directly on the equator of the Earth. And as the Earth rotates during that day, the sun will be directly over the equator for that day. And it gives us 50% daytime, 50% nighttime. The sun rises in the east and sets in the west, except for a few exceptions. And so that the instant that the sun crosses the equator, that's when spring begins. And it's because the sun is entering the northern half of the sky, the northern bowl of the sky. It's predominantly shining onto the northern hemisphere of the Earth, and it gives us the longer daylight hours, the warmer temperatures, and so on. And then if we advance into 3 months around the June solstice, so at the June solstice, the sun is now, it's at its farthest excursion north of the celestial equator, which means it rides highest in the sky at noon and takes the longest to travel across the sky from dawn until dusk. That's the longest day of the year. All right. And then 3 months after that, you get to September solstice. And again, the days are a little bit off here and there. So the sun is now crossing the equator, heading into the southern hemisphere and giving them the opportunity to have their longer days and their warmer temperatures. And to finish the thought, when we get to the December solstice, that's the time of the year. And by the way, I have to turn off daylight savings. That's why it went a little crooked on me here. The sun is now at its lowest point, or its greatest point south of the celestial equator. And then it gives us our shortest days and our weakest sun, because the sun is actually shining sort of obliquely onto the northern hemisphere and the rays are less concentrated. So that's another reason why we get colder temperatures. So it's called insolation. All right, so let's go back to March. Here we go, and add our daylight savings times. So when you think about this, the way that the seasons work, we've got the vernal equinox or March equinox is basically kicking off springtime. So that's when the flowers are blooming, the animals are coming out for people to, the ancient people to hunt them and the indigenous people and so on. Then in September, the September equinox, we're dealing with the days getting shorter, the weather cooling down, the harvest time approaching. And so it's not surprising that people would be kind of celebratory and creating cultural events or social events around those two parts of the year to celebrate the time for renewal in the spring and the time for collecting the harvest and appreciating the bounty of nature in the fall. Now the two solstices in December and June, they're going to give you the longest night of the year in December, and they're going to give you the shortest night or longest day of the year in June. And so there are midwinter and midsummer festivals and things around that. So let's get into the quarter days. Now, in terms of knowing what season it is, if you were to be an observer and you were, say, wanted to set up a stick in the ground and never touch it for the year, you could measure the sun's shadow cast on the back of that stick, and you could tell when the length of that shadow was the shortest, that would be your June solstice, right? And when the shadow was longest, that would be winter solstice. When you see the sun rising in the east and setting in the west exactly, then you know that you're at the equinoxes. And eventually people would start building, erecting stone structures that would enable them to use a notch or a hole in the wall to project sunlight through a hole, and they would know exactly when they got to those points of the year. So those were kind of 3D calendars, if you want. So that was important. I should mention too that some countries don't think of spring, the seasons, the way we do here in Canada. Let's see, I think it's some of the Scandinavian countries, they use something called meteorological seasons, where they just pick the first of the month in which the equinox or solstice occurs. So their seasons start on September 1st, December 1st, March 1st, June 1st.
Interesting.
That's different.
This also is a complete divergence. It comes into play when it comes to summiting mountains in the winter as well. What counts as winter?
Sure.
That happened this year with K2.
Obviously, it's important to know when things are happening, because you want to plan planting and reaping and harvesting and things like that. Yeah. All right. So this is what I think is really cool. And this was something that I think is fun about astronomy, that you get to learn these other extra fun facts. So cross quarter days are the midpoints of the seasons. And you and I have talked about this before. It's fun. It's not obvious when these are happening, because there's no particular thing that the sun and the earth are doing that sort of clues you in. You could do it by knowing how long the year is, and then how long a quarter of a year is, a season, and then doing some arithmetic and saying, well, so many days since spring or since the beginning of winter. But you can't really do that, because the earth is traveling on an elliptical orbit around the sun. And that means that it speeds up and slows down according to whether it's at perihelion, near the sun, or aphelion, away from the sun. And as a result of that, perihelion happens every year around January 4th, right? Some people think that it's cold in the winter because we're farther from the sun, but it's actually the opposite. Perihelion is when we're closest to the sun in early January.
There's also a huge misconception that every once in a while makes the rounds on the internet where people say if the Earth was 10 feet closer to the sun or 10 feet further away, then we would all be dead. And it's like, nope, the Earth varies in distance quite a bit more than 10 feet.
That's right. Yeah. So because the Earth is moving faster in its orbit in January, it means winter is shorter. Winter is about 5 days shorter than summer.
Yay!
Yeah. Let's see. So spring is about 92.75 days. Let's see. Summer is going to be a little longer. Yeah. So the average is 91.3. Spring is a day or so longer than that. The Northern Hemisphere summer is longer by about 5 days. Autumn is about 90 days, and winter is about 5 days shorter than the average. So we get through winter faster. Now in the Southern Hemisphere, it's the opposite. They get extra long winter, extra shorter summers.
Maybe they like the cooler temperatures. Who knows?
All right. So,
oh, geez.
Cross-quarter days. So the cross-quarter days happen at the midpoints of the season. And the first one, the one we just had, happened around February 3rd, astronomically speaking. So February 3rd in the morning, that was the midpoint of winter. And that used to be celebrated as the Celt and Druid pagan celebration called Imbolc, Imbolc. It was a traditional time for initiations and things like that. But we know it better as Groundhog Day.
Oh.
So Groundhog Day happens when it does. It's because it's a cross-quarter day. And it actually is the midpoint of winter. And there is actually 6 weeks left of winter, no matter what.
Huh, that's awesome.
Now, a lot of these pagan, prehistoric, or early society celebrations were adopted by the church when the church was working in their missionary efforts to bring more people into the fold. Then they would often overlay a church celebration on top of an existing celebration, so that didn't have to radically alter people's behavior very much. So at around Groundhog Day, we also have a Roman Catholic church celebration called Candlemas. Now the next cross-quarter day happens in mid-spring, and that's going to be on May 5th in the morning. And that you may know as May Day.
Oh, yeah.
So May Day is around 5th. So it's a time to celebrate romantic love, fertility, spring flowers. The Irish pagans called that one Beltane. The reason I keep mentioning the Irish and the Druid and the Celts is because if you know anybody that's into, Wicca or spirituality, they'll often use the Celt and Druidic calendar and some of these names. Mm-hmm. So Beltane actually means lucky fire. And there's a kind of a fun story about jumping over a bonfire to ward off evil spirits, or making your cows jump over the bonfire so their milk would be better and things like that. Yeah, it's fun to research some of this stuff. Now, in Roman times, they celebrated an event called Mayoma, and that's where the word May, the month of May, comes from, Mayoma. It was to honor Aphrodite and Dionysus. I'm just going to stop my share for a second. Oh, you got my share off? Okay. Aphrodite and Dionysus. And it may have actually originated the idea of the orgy. So I saw the word orgy mentioned in there. Now, in the not to make a right turn here, but the May 5th time of the year is in the Catholic Church. It's their May Day. They're celebrating the Virgin Mary. You may have heard of Cinco de Mayo, which is May Day, May 5th. Mm-hmm. But it does not have to do with any of this. It actually is the anniversary of a battle that the Mexican army was victorious in that happened to fall on that date. So Cinco de Mayo is not the same as May Day in terms of cross-quarter day. All right, so then we get to the midsummer. So Shakespeare's Midsummer Night's Dream. We have various celebrations of midsummer. This one was used to celebrate the early harvest because they were starting to already take vegetables out of the garden and take crops from the fields. the pagan term for the Midsummer Festival is Lunasa, spelled with lots of G's and H's, or Lamas. And that term refers to grains or bread. And you may have already noticed that the word Lamas resembles the word Lembas from Lord of the Rings. And it's thought that J.R.R. Tolkien adopted the word Lembas for his way bread, his elven way bread, from that Midsummer Festival name on the same route. All right, final one happens in early November. This year it's going to be on November 6th in the morning, and it's called Samhain. And you could think of it as pagan Thanksgiving. So it's really to celebrate the end of the harvest. And the story there is that at that time of the year, the barrier between our world and the other world thins, allowing spirits to come through and fairies and things like that, if you're into that sort of stuff. So you may have heard of it as All Saints Day, or perhaps the evening before, which is All Hallows Eve or Halloween. So that's why we celebrate Halloween at the end of October, is because it's piggybacking on the autumn cross-quarter day.
Right. And it shifted backwards, didn't it, for some reason?
So,
with the calendar?
Yeah, so some of these things got shifted around because of the mismatch, the out of sync with the Orthodox calendar.
Right.
I'm not sure. Yeah, we'll come to it in a bit. So tomorrow is St. Patrick's Day.
Oh yeah. Is it really?
Yeah.
Wow. Yeah, it is. Time marches on.
And St. Patrick's Day originally was meant to be on the March equinox, but because it was established by the church in the 12th century, in the intervening years, it's drifted away. It moved off, right? Because it was done by the Orthodox Church, so it was offset from the true equinox, the 21st of March time. All right.
There's also something to do with, I think around Samhain as well, that's about the time where the Pleiades start rising right at sunset. Or sorry, yes, that's correct, I think. And so that helps people keep track of the timing. And that used to be the sort of measure as well when they were going to have their celebrations.
Yeah. So in fact, I was just going to talk about heliacal rising.
Oh, sorry, I didn't read far enough.
Perfect segue. So a heliacal rising is the word helios, is the sun. So heliacal rising is when an object clears the horizon at the same time as the sun does. Now that usually makes it a little tricky to see it, but if the object's bright enough and your conditions are fine, and your horizon's open and free of clouds, I mean, you can see it. So many ancient cultures adopted the heliacal rising of an object for their calendars, as opposed to what the Earth and the Sun were doing together. And by the way, of course, it doesn't work for planets because the planets are drifting around all over the place. So one of the main examples of this are the South Sea Islanders. So the South Sea Islanders, the New Zealanders, the Hawaiians, the Cook Islands, people in that corner of the Pacific are all kind of related from the same root peoples. They navigated the sea, they told time using the stars, and of course they had these beautiful horizons of the ocean, flat ocean, and they could see stars rising really nicely over the ocean. So they use those a lot. The ancient Greeks used the appearance of the Pleiades, as you just finished saying, to define when it was sailing season. So the Pleiades cluster, I'm just going to bring up my stellarium here. I'll share my screen again here. There we go. So the Pleiades, let's see if I've got here, 45, Athens, Greece. This should do it. All right. So what I just did is I took us to Athens, Greece, in the year 0 in the springtime. And around this time of the year, early May every year, the Pleiades would rise just around the same time as the sun, or just before the sun would. And so then when the sailors began to see the Pleiades appearing before dawn, they knew that sailing season had begun. And at the same time, I don't know if I have the other one, I won't do it right now, but It turns out that if you use stellarium and you set it to the late October, then that's when the Pleiades will start to rise after dusk. So it's after dawn in the spring, and it's after dusk in the fall. And that would be the end of sailing season. And I read today that the Pleiades, the name Pleiades, may be derived from the Greek phrase plein, and not from Pleione, the star, or the mythological character, but from the word plein, which is in Greek to sail.
Oh,
yeah,
that's cool.
Yeah. And I think that makes sense.
That does
the other neat one is Sirius, the helical rising of the star Sirius. So I'm going to click us here, and I'm going to set us to. So I've just, pardon the grass, but I've just parked us in ancient Cairo. And we're sitting here in the year 3000 BC in the month of July. And what we have, I'm just going to set my horizon to a flat horizon here. So there we've got the star Sirius marked, and it's rising with the sun around the 4th of July, early July. So somebody's job was to get up before the sun and watch the eastern horizon and wait for the star Sirius to rise along with the sun. And the reason that was important because that was linked to the arrival of the Nile flooding. And that was important in the Egyptian calendar. The Egyptian year was divided into 3 seasons. They had Akhet, which was the inundation or the flooding time of the year. They had Peret, which was the growing time of the year, and Shamu, which was the harvesting time. And so Akhet was this part of the year where the star Sirius would appear above the eastern horizon with the sun in the morning. All right. So now we can move. You have any questions? We're going to switch horses and now talk about religious festivals.
Some of the questions are really complex, and I'm looking at you, Robin. They're great questions, but they're very complex. So I'm going to save them to the end. There's one quick question about at what date does midsummer occur?
So
was that that was the August the 6th one?
Yeah, midsummer cross-quarter day, I said, is August 7th.
August 7th. So that is the official middle of summer.
Yeah, but it's not the longest day of the year. That's the solstice. Yeah,
it's the middle of the season that follows the longest day of the year.
That's right.
Yeah.
So really,
else we're going to say at the end.
Go ahead.
All the other questions we're going to save for the end, so we can march forward.
All right. Let's see. Okay, let's talk about what we said we were going to talk about. That's religions. So, as I said before, a lot of people had already been celebrating at the various corners of the year, right? The various solstices, equinoxes, for the reasons that I mentioned before. Saturnalia, that you may have heard of, that was a Roman festival that was being held around the December solstice. And Pope Julius, at some point, I don't think I wrote the year. Pope Julius of the Catholic Church, he decided that Christmas should be assigned to the same Saturnalia period celebration. And he had a couple of reasons for that. So he may have wanted to encourage the Romans or the non-Christian, the non-Catholic, non-Christian people to continue to celebrate when they normally were, but now for a Catholic Church purpose, for the Christian Christmas. And another story is that Jesus was said to have died on the anniversary of his conception. Now, the story goes that Jesus was arrested and crucified because he went to Jerusalem, for Passover. And we knew when Passover was, because Passover is tied to the calendar, as we'll get to in a couple minutes. So we know that Passover is happening near the March equinox. And so that's when Jesus was conceived. Then he must have been born 9 months later at the winter solstice. And so that's a couple of possible reasons why Christmas has been scheduled for around that summer time. Let's see, we can talk about, Kwanzaa. Kwanzaa's interesting.
Before we move on, can I just plug one of our past YouTube videos?
Yeah.
Okay. We had a talk around the time, actually around Saturnalia / December 25th. It was on December 18th, around the time of that great conjunction last year where Jupiter and Saturn got real close together. And it was about the Star of Bethlehem. So if you're interested in that, I have just posted the link in the chat. It's on our YouTube channel as well. On December 18th was when we posted it. Super interesting talk, worth a watch if you're interested in astronomy and how religion and astronomy intersect.
Cool.
Back to you, sorry.
That's okay. That's what I love about astronomy is that there's history, there's mathematics, there's
so many different ways to look
exploration,
at it.
all kinds of things you can do.
Yeah.
All right. So while we're kind of in the topic of stuff that happens around Western Christmas, so Kwanzaa. So you hear people being wished a happy Kwanzaa and that kind of thing around the Christmas time. And I wondered whether Kwanzaa had an origin as well that could be tied to astronomy. But in fact, it does not. So Kwanzaa is a secular holiday invented by an African-American gentleman named Maulana Karenga in 1966, after the Watts riots in the US during the time of the civil rights movement. He wanted to give Blacks, African-Americans, their own holidays, an alternative to the sort of what I guess he saw as the more white holiday of Christmas. So Kwanzaa was created, and it's set to run every year from December 26th to January 1st. So it has nothing to do with the astronomy or the calendars. It was something that was offered as an alternative to Christmas time. A couple other ones that are running around that time of year. So you have Hanukkah. So Hanukkah is a Jewish festival, otherwise known as the Festival of Lights. And it's observed for 8 days and nights, starting at sunset on the 25th of the Hebrew month of Kislev. And we'll get into the Hebrew calendar in a little bit. But that generally runs from late November to late December in the calendar. And this year, that will be on November 28th for those that are interested. The Persians, they celebrate something called Yalda, which is their longest night of the year around the December solstice. The Incans, the Peruvians, they observe something called Inti Raymi, which is celebrating the sun god for them. Now, that's happening on December 21st, but that's their summertime.
Right.
Their summer solstice.
That would be their summer solstice because they're in the Southern Hemisphere, true.
The Scandinavia, they celebrate St. Lucia's Day, another festival of lights. That's around December 13th. And that's what they used to kick off their Yule celebration, their Yule season. And I mentioned St. Patrick's Day. And what else? Oh, and we have in Canada, we have National Indigenous Day celebrated on the summer solstice. And that was chosen as a significant day of the year to honor the Indigenous culture in Canada. All right. So we haven't talked about the moon that much yet. And now this is where things get interesting. So the moon is a great way to mark time because, as I said, it's easy to see it. Anybody can see the moon. They don't need to have gotten their stick out and measured the length of the sun shadow and anything like that. So, but they can tell that the months are passing by because of the way the moon is cycling. So the moon phases repeat every 29.53 days. That's called a lunation. And therefore, that means that there are 12.38 lunar cycles in a calendar year, in a 365.25 day year. So that means we can fit 12 1/3 months in a year. So that's a mess.
Yeah, that's not balanced. That's not fitting in nicely to any of the math that we already have.
Yeah. So various cultures around the world obviously recognize that from years ago. And I'm talking about Indigenous people all around the world, as well as some of the more organized religions, you know, the Christian church and the Hebrew scholars and the Islam calendar, things like that. So they essentially all worked out that their calendars would be basically 12 months and a spare month inserted every now and again to keep things on track. except for the Islamic calendar, which I'll get to in a couple minutes. So let's start with Easter and Passover, which are coming up not too long from now. So they're connected to the moon. So, and Passover, of course, predated the Christian Easter celebration. And a lot of people thought that that was chosen. The reason the moon was connected with those celebrations, those ceremonies, was because the full moon allowed the safe travel of pilgrims in the night. So it illuminated the sky at night and allowed people to travel farther, longer at nighttime with the moon. So as I mentioned, the Council of Nicaea in 325 AD. So they decided at that meeting that the Easter should be observed on the Sunday that follows the first full moon that follows the vernal equinox.
The Sunday that follows the first full moon that follows. Okay. Okay.
Yeah. So this coming Sunday, we're going to have the March equinox.
Yeah.
Okay. Then there's going to be a full moon after that at some point.
Right.
I'll give you the dates here in a minute.
Okay.
And then you're going to count beyond that to the Sunday that's following that. So that full moon that follows the equinox is called the Paschal, Paschal full moon. Paschal full moon. All right. Now that means that because the moon is not tied to what the earth and the sun are doing in terms of the equinox, that Easter floats around. It's called a movable feast. It's one of the movable feasts, if you've heard that expression, because it varies a little bit. So that means that and not only that, but of course the equinox can also move it by a day or two because of the leap years and things like that as well. So if the post-equinox full moon falls on the Sunday, then they delay it a week to the following Sunday. Right. So the earliest that Easter can ever happen is March 22nd. That last happened in 1818, and it won't happen again until 2285. Wow. So that's the early Easter. If the full moon happens before the equinox, then they'll delay Easter by a full month because they want the time of year to be the warmer weather coming. So and then plus up to 6 days. So the latest Easter can happen in late April. Will be in next time it'll be in 2038. Will be a late April Easter. Wow. So this year the equinox happens this Saturday at 9:37 GMT or Greenwich Mean Time. So that's basically Saturday morning. And that's 1 week after the new moon. So the new moon was just happened on Saturday. Then the full moon that follows that is going to be on March 28th. That's a Sunday. And so Easter falls on the week after that, April 4th. So this year Easter is on April 4th. The other things that are associated with Easter will be Lent, Palm Sunday, Ascension, Pentecost. So if you're interested in researching the timings of those, they're all linked to wherever Easter lands. Those are all synchronized to that. And even Mardi Gras and all those things are all tied to the same events. Now Passover is linked to the Jewish calendar. So the Jewish calendar has a month in it called Nisan, Nissan, and I apologize if I'm not pronouncing these properly, but I'll do my best. So the Jewish or religious Hebrew celebrations always start on a sundown. They count their days to go from sundown to sundown. And by the way, that means that the length of Jewish or Hebrew days varies through the year in the sort of Orthodox.
Oh, true. Sense, of course it would. Yeah.
Right? Because their day lengths in the winter will be short.
Yeah.
And it varies a little bit, but anyway, you get what I mean. So Passover is celebrated from sundown on the month of Nisan, the 15th day of the month of Nisan, through the 22nd day. So this year, that means Passover starts on Saturday, March 27. And the full moon will occur in Israel time at 9:48. So they tend to anchor it to home base, if you like, where the time is on Israel. Let's see. In in years where the timing of the full moon causes everything to be a little early, then the scholars will actually declare it to be a month later, because they do want the Passover to be happening at the warmer time of year. When they've got the flowers in bloom, things like that. So let's see, the earliest that can happen is March 25th. That will happen in 2089. And as I said before, the Eastern Orthodox religions, they're still using the old Julian calendars. So their celebrations are all delayed with respect to us. The benefit of the Eastern Orthodox calendar is that they ensure that Easter always happens after Passover. And the logic there is that, as I said earlier, that the story is that Jesus was where he was to be arrested because he was attending Passover at the time as a Jewish observant. All right. Now, the Islam calendar is interesting. So the Islam calendar, go ahead.
Can I jump in? Because we also missed a Persian celebration in March, which is Nowruz.
Just getting to it.
Oh, God, sorry.
That's okay. That's okay.
Okay,
like I said, I don't have these in perfectly logical order, but yeah, thanks. Yeah, we can talk about Nowruz. So Nowruz is happening. Nowruz is their New Year's celebration for Persians, and it actually happens at midnight on the day. So the midnight that happens closest to the equinox in March.
Oh, okay.
Now, because the equinox happens in early morning this year for us, so Nowruz actually occurs on the equinox day, because it would have started at midnight that day.
Right.
So that's going to be this coming Saturday is Nowruz. Nowruz, N-O-R-O-O-Z, or different spellings, means new day, and it's the Persian New Year. The Persian calendar originated with the Babylonians and has been gone through a number of iterations and adjustments along the way. It's based on the sun, but not the moon per se. And the Persian calendar uses 12 30-day months, and they insert an extra month every 6 years to keep things on track. So that's the Persian calendar. Yeah, cool.
Sorry, didn't mean to jump you ahead.
That's okay. That's okay. So the Islam calendar is interesting. So the Islam calendar is strictly moon-based. It's lunar-based. So it's not linked to the sun, moon, the equinoxes, or the solstices. That means that the Islamic calendar drifts because it just strictly follows the moon. So you'll probably heard of Ramadan. Ramadan is the month-long celebration that the Muslims follow. Ramadan itself is one of the month names on the Islamic calendar. So it's the 9th month of their calendar. It begins, now the Islamic calendar actually is tied to the first glimpse of the young new moon crescent moon after new. So there are scholars whose job is to be ready to look for the first glimpse of the moon, and that would declare the beginning of the month, each month, with the first sighting of the moon from Mecca. And then that gets distributed around the world. And of course, nowadays we all, I'm sure there are people who are using Stellarium or other software to calculate these, and not necessarily have to see them, but the tradition is to be able to see it visually.
And then there's a whole, astronomy-wise, there's a whole competition to see who can get the photo of the thinnest moon as well.
Yes. How young of a moon can you get? All right. So, and by the way, this time of year is good for that because the ecliptic is quite vertical in the evening. And that means you've got your best chance to see the moon with the sun a bit lower below the horizon. So yeah, Ramadan is the 9th month of the calendar. It's always the new moon that follows let's see. Yeah, so Ramadan is going to starts at sundown on April 12th and end on Tuesday, May 12th. And if you're sighting the young moon, look for Venus. It'll be just above the horizon along the crescent moon. I don't know if I can show that here. Let's see if I can show
Is that this year? The
yeah,
Venus
this year.
Oh, yay, isn't that nice?
So April 12th. Let's see if we can find the young moon here. And around sunset's quite late. I gotta go back a day here. So have I got the moon or not? Let's see if I should have it. Let's see if I can find the moon for us. We have, I may be off a day here. Here we go.
Oh, wow.
So there's the moon. Yeah, there's the moon on the 13th, the moon on the 12th.
It's too close to the sun.
The reason this is wrong is because I'm not doing it from Mecca.
Right, fair.
So if I change my date to Mecca, then we'll get the moon just above the sun for that given time. So that's why that's off.
Cool.
All right, let's see. Let's talk a little bit more about the Hebrew calendar and some of the ramifications of that. I have to say that it's an extremely rich topic for reading about. There's a lot of complications, complexities, interesting history behind them, changes over time. So I'm just going to skim the very the very surface of the topic.
Very surface, yeah.
But so as I said before, the Hebrew calendar is what they call a lunisolar calendar. So a lunisolar calendar combines both the behavior of the Earth and Sun plus the appearance of the moon in the sky to mark the months. The Jewish calendar, or the Hebrew calendar, uses the sunset as the trigger for the beginning of a day, and that causes the day length to change a little bit throughout the year. They have a 7-day week that's thought to mirror the 7 days in the Old Testament in the book of Genesis. That's where the concept of the 7-day week would come from. The months all begin with the new moon and the first glimpse of the young crescent, just like the Islamic calendar. Obviously, the two groups share a lot of similarities, being from the same part of the world and have that in common. Now, because of that half-day difference in the 29.5-day cycle of the moon's phases, so the Jewish calendar uses a combination of 29-day months and 30-day months. Okay, so the 29-day months are called chaser or chaser, and again, there's probably a k sound that I'm not getting right. And the 30-day long months are called Malei, M-A-L-E-I, or full months. So the 29-day months are called missing months, or missing a day, and then fuller months. To make sure that the calendar doesn't drift out of sync with the seasons, then they insert an intercalary month, a 13th month, every now and again, 7 of them every 19 years. So it's on a bit of a strange schedule, or a schedule that dictated by the way that everything works. And what they do is they double up one of their summertime months. So they have a month called Adar in the summer, and in the years where they need an extra month, they have an Adar 2 back to back. There's still a bit of a drift in their calendar that I think runs off about a day every couple hundred years in their calendar. So now, the month of Nisan that I mentioned, the one that had Hanukkah in it, is the first month of their year, but it's not New Year's. So New Year's actually happens in September, in the 7th month of the Hebrew calendar. So the 7th month of the Hebrew calendar is called Tishrei. It's always in September, October in our time frame, on our calendar. And it contains all the Jewish high holidays, right? So it's got Rosh Hashanah, Yom Kippur, Sukkot, Shmini, Atzeret, and Simchat Torah. And I don't know what all those are, but I put them out for you. Rosh Hashanah is New Year. So it falls on Tishrei 1, or the first day of that 7th month. Yom Kippur, the Day of Atonement, falls on Tishrei 10 days later, after an intervening so-called 10 days of awe in their religious traditions. So that's just a taste of the Hebrew calendar, and I'll leave it at that. Let's see, how's our time doing? Oh, we're okay.
We still have half an hour.
So let's talk about China. So China also adopted a lunisolar calendar. So they work it so that they put the 11th month of their calendar they make sure that the December solstice is in the 11th month of their calendar. Okay, it's the way they work it.
Okay.
So that means that the first day of the next year, so 11th month, then 12th, and then the first month of the new year, always lands in around between January 21st and February 20th on our calendar. So that's why you hear about Chinese New Year happening towards the end of January or in the middle of February. Most of the time it's in early February. So the Chinese Lunar New Year, which I just mentioned, officially it happens when the new moon occurs Beijing time. And then that gets celebrated accordingly around the rest of the globe. So this year that was on February 12th. So February 12th in Beijing, but February 11th in Canada.
Mm-hmm.
Yeah, the way that works. It also starts their spring festival called Chuanjie, and that runs for 2 weeks. So it starts with the new moon and ends at the full moon that happens at that time of the year. And again, as I said, just like the Jewish calendar, they get occasionally an extra month inserted into their calendar. Now, I thought this was cool, and it's not really on our topic, but I want to talk about for a minute about the Chinese zodiac, right? So we're in the year of the ox. I think we just started the year of the ox. So the Chinese use the zodiac system, which is a 12-year cycle where it's a set of animals. So last year was the rat, this year is the ox. And they use the word zodiac in this case is meant to be used in the sense of the word zoo, because the cycle is all different animals. And I wrote in my skylights a few weeks ago the story about a famous race that determined the order of the animals and how the rat cheated and ended up first. So, but that's sort of cleverness. So he gets points for that. But the neat thing is that some scholars think that the 12-year cycle is connected to the 12-year period of Jupiter's orbit. So that's cool.
That's kind of cool.
Yeah.
Yeah.
Let's see what else we have here. So we should talk about. Well, we can talk about a couple of the other festivals. They have the Lantern Festival that they celebrate at the end of the Chinese New Year period. So that's that full moon at the end of the Chinese New Year period. They have a Mid-Autumn Festival. That's when they eat the moon cakes. And that happens on the September equinox.
Oh, awesome.
But let's talk about the Big Dipper here. Let's see if I can find the Big Dipper.
I've also just sent out Chris's website in the chat. I tried to, part of the reason I'm not responding that much is because I have no idea about any of this stuff and I'm learning it all for the first time, just like all of you. But the second reason was because I was trying to find that particular article, which I did not succeed in doing, but you can just browse his website and it has tons of information on there.
Yes. Let me just get this. Oops. My daylight turn on. There we go. Turn on my daylight here for a second. Beijing. Okay, I'm not sure why this is not working right, but so in China, the Chinese astronomers use the position of the orientation of the Big Dipper to help them mark their seasons. So let's see if I have this right. Yeah. So before dawn, in around the March solstice, and again, I don't have the daylight properly here. I'm not sure why. Let's see if I can get the sun to go down. Here we go.
You're in Beijing at the moment, that's why.
There we go, yeah. Yeah. So before sunrise at the March equinox, the Big Dipper is always standing upright on its handle. And so the farmers, when they see the Big Dipper, they get up early. Farmers get up early. When they see the Big Dipper standing upright on its handle, they know that's the time of year when they need to be planting. 3 months later, and I'll just get the sunrise. So I've got my timings off a little bit
Yeah,
here.
the
but
dates, the times.
at
Funny.
each, yeah,
We're at
with each,
sunset at the moment for some reason.
yeah, this is weird. I don't have the right times here. Let's go back. Yeah, if we go back to the morning, it's not, somehow
That's super
Starry is
weird.
not reporting the time properly. Here we go. So in June, at the June solstice, then the Big Dipper orientation is horizontal over the northern horizon before dawn. And then 3 months after that, it's upright. And 3 months after that, it's horizontal, high in the sky. So anyway, the 4 orientations mark the 4 seasons using the direction of the Big Dipper. All right. So I just had a couple more things to talk about. Let's go back to here. Let's go back home. I'll set this up for the next thing here. Reset here. Oops. My Stellarium's gone funny. Here we go. Back home. Now, close this up. So in most of the indigenous calendars and observances, they again use the appearance of the moon in the sky, and they actually, as you know, assign different names to each moon period. One of our members, Dave Chapman, often shares the information about the Mi'kmaq moons.
Yeah, I'll get the link for that and send it out.
Yeah, and those are both tied to the appearance of the full moon in the sky, but also the new moon, the missing new moon in the sky. And according to the various times of the year, then the moon names remind people about what's happening in nature or the activities they should engage in. So things like harvesting sap or, planting and harvesting and so on.
In this case, when you're saying Indigenous, you mean Canadian, North American Indigenous, sort of.
Well, it's really true for Indigenous people all around the world. A lot of Indigenous groups do a similar thing, but I'm talking about the Canadian, particularly the Canadian Indigenous groups for sure. I like to highlight them in my skylights just because I think it's great to share that knowledge as much as we can. Now the Maori people, I mentioned the Maori people.
I'll bridge this gap nicely because, and I'll just share another link as well in the chat. Annette Lee and the Native Skywatchers have been putting on, or Annette Lee is part of the Native Skywatchers, and Native Skywatchers have been putting on series with NASA about Indigenous astronomy in different cultures. And they just recently, they've done a whole bunch of different ones, Ojibwe and Lakota Dakota and tons. I think they're on their 6th now. And I'll send the link out. It's not quite ready yet. They don't have the recording up, but last week they had a show on Hawaiian astronomy. And so keep an eye on that link because it was particularly fantastic if you want to rewatch the Hawaiian astronomy show. And now on to Maori astronomy and calendars as well.
All right, so let me pick the correct link here. If I have this right, I should now be in Auckland, New Zealand. And I'm gonna put on an ocean background. Here we go. So the Maori also use a lunisolar calendar, so it's tied both to the moon and to the sun and the earth. They don't use weekdays the way we do it. What they do instead is they assign a name for each daily phase of the moon. So they would essentially have 30 different days in their cycle before they begin to repeat through them again. And each day of the moon cycle or each set of days actually teaches them how they should be in relation to each other and in relation to the ocean, and when to venture into the water, when to stay out of the water, when to plant and harvest, even when to fell trees for lumber and art and things like that. It's all taught in their traditional teachings around the moon and the moon names. The Maori New Year begins with the month of Pipiri in May and June. And that happens when the full moon rises in the east opposite the Pleiades. So the Pleiades, they're named for the Pleiades in both New Zealand and also in Hawaii. So they use the same name in the Hawaiian session that we watched was Matariki, which is basically the Pleiades star cluster that we know. So in May, late May, the Pleiades will set in the west. So let me just get this right. I've got the Pleiades. I should be able to center it here. So the Pleiades are setting in the west, opposite the moon on the other side of the sky. So they're linking the beginning of the month and the calendar to the appearance of the Pleiades, kind of a heliacal setting, if you like, of the Pleiades with the sun, and also with the setting of the full moon. So that's what they do. And just to wrap up, and then we can open up to some questions if there are any questions, or if people want to share their own experiences that maybe with cultures that I haven't touched on, is I want to bring it back to Canada for a minute and talk about something I learned recently that I thought was really interesting, and that's the Nisga'a people of British Columbia. So they're an Indigenous group that live in British Columbia, and they actually celebrate the new year when the crescent moon, the one that's over my shoulder here, if I get my camera right, first appears in February or March, and they call that celebration Hobie. I'm not sure exactly how it's pronounced. It comes from an expression for the Hobixis he, and that means the moon is in the shape of a hubix, and the hubix was their spoon. And they're talking about the fact that the moon looks like a scoop.
Yeah.
At this in sort of the February, March, as I mentioned, in February, March, when the moon sets. Let me just go back to, see if I can go back to, I'll go back to Canada here. Sometimes when you use the bookmarks,
it takes you to strange places.
It does take you to strange places. So I'm just going to set it back to Toronto, Canada, and close this up. Okay. So if we go back about a month and we get the moon, and we set that back to crescent moon setting in the west after the sun. So again, they keep their eye out for the moon after sunset at this time of the year. And because of the ecliptic is rather steep in the west, the moon makes that nice scoop shape. The crescent moon makes that nice scoop shape. So it's the orientation of the moon after sunset. The horn tips are pointed up, resembling a scoop, ready to be filled with the abundance of salmon and the river, the candlefish that they harvest from the river, berries and more. Children run around with their arms up to mimic the moon and calling out the name. And they call the first month of their year is called, I'm going to butcher the pronunciation, I'm sorry, but it's Buxwa Lax, where Buxwa, B-U-X-W, means to blow about, and lax means needles. So when the needles are started, the snow is gone, and the needles that have been laying on the winter floor of the forest begin to blow around. That's the sign of winter's end, and that's their new year.
Oh, that's nice. I like that.
So I'm going to stop.
Okay. Wow. That was a lot of information and a lot of really amazing ties to astronomy and just so cool to hear so much about it. Thank you, Chris, for sharing all of that. I certainly knew almost none of that before you started, so I really appreciate it. Atul Dave has shared in the chat with us that the Hindu calendar is very similar to the Muslim calendar and is also moon-based. And also this may be an option for you to show us right now, Chris. In Stellarium, you can select language and religion and check the name of astronomical objects by religious name. We've done this before with some constellations. Could you just show how to find it again?
Yeah, so let's do, let's see, let's go to now, and I'll go to tonight. So here's the sky tonight. And what you can do is you go to sky and viewing options, that's F4. You can just hit F4, or you can mouse over and click on this. Then there's different tabs here. You want to click over to star lore, and then pick your pleasure. So let's see if Hindu is in here. Here's Indian Vedic. That may be good enough. Oh, I guess Indian Vedic means the zodiac for them.
Okay.
Let's see, are there any other here? And
That's
again, I do take requests, but what I'll do is I'll also bring up the artwork. So there's the artwork and see, yeah, okay, they're using the Western artwork. Let's pick another one. Let's go Egyptian. I think Egyptian's got some different artwork, or Arabic. So there's the Arabic.
Oh, wow.
So you can see how Stellarium will actually show you different sets of artwork. And that's being added to all the time, which is really, really fun.
Cool. Also, clarification from Atul as well. Vedas are original scriptures of Hindu. So that's where that term comes from. Thank you for showing us that. And I definitely encourage folks to go in there and explore around and check out different constellations in the sky. Shall we dive into some of the questions from earlier, which I have been putting off because Robin is better at this than I am, and I'm not sure how to summarize them. So first, I'm going to start with Louis or Lewis. I'm sorry, I don't know how you pronounce your name. Their question that is, when we start true space travel, would a new calendar be in an option or something that might be worth doing, like in Star Trek Stardates style?
That's an interesting question, isn't it? Because humans have evolved with a circadian rhythm that's tied to the behavior of the Earth and the sun and so on. So once we leave Earth permanently, we don't really need that. I mentioned Mars. If you're going to live on Mars, you're going to need to adapt to Mars's different day length.
Mm-hmm.
And we'll just have to cope if we have Earth-Mars commerce and dealings, we're going to just have to adjust to that. Just like if you have a loved one that lives in New Zealand, like I do, and you have to figure out, is it time or not?
Yeah, that's always the tricky part, is that those time conversions. We already have so many, and then we're going to have so many more.
But I think there's a good argument there for starting over with something logical, like a metric time and date system for when we become interstellar. Yeah,
it's going to be interesting then you have to also deal with lag, which comes up in the Expanse series, but we won't go there. If you're interested in sci-fi, we've already done a sci-fi series, but in the Expanse, or for anywhere, whenever you're traveling, if you're going to be out around Saturn, it's going to take, is it on the order of like an hour or so for your message to get back to whoever you're sending it to on Earth. We already face this with our spacecraft, but once we're sending voice messages and videos to people over distances like that, we'll have to deal with it then too. Okay, on to Robin's questions. Okay, the first one is, and we have a bit of an answer for this possibly already, can you explain why the vernal equinox or the spring equinox in the northern hemisphere is not the day on which there are 12 hours of sunlight and 12 hours of nighttime in Ireland and Canada? That day is March 17th on St. Patrick's Day, give or take a day. And Warren responded saying it's because we're not on the equator. Is that right?
Yeah, it varies a little bit with latitude. Yes, indeed it does.
Thank you, Warren, for jumping in on that. We have a question from Chris, which is not you, a different Chris, which is there a prediction as to, we were talking about tidally locking with the moon and the moon facing us. Is there a prediction as to what part of the Earth the moon will face?
Interesting question. Well, you would think that the part that's going to face the moon would be the part with the densest crust.
So wherever that is.
So probably, I would say Eurasia. I would say probably, because any place you have mountains, then the crust is deeper and thicker. So there's a little more mass distributed closer to the surface of the Earth.
Mountains and not volcanoes, to be clear.
Just mountains, yeah. Mountains have roots, so when a mountain goes up, it also creates a root below it.
That's cool.
And because the bottoms of the oceans are going to be a little bit farther from the moon and the tops of the high elevations, the dry land will be a bit closer to the moon. So maybe something like, yeah, a kind of a weighted average between Africa, Europe, Asia, that sort of side of the hemisphere of the Earth. That would be my guess, but
Okay.
it's fun. I had never thought of it before.
Yeah, it's a good question, and it's going to be interesting because when we've been looking, we as human beings, not me personally, when we've been looking at exoplanets around other stars, we often find planets that are tidally locked with their parent star, and then that brings into question how viable is life on those planets, and if it is viable, where is it viable? Is it only viable around the edges where it is permanently sunset or sunrise? Because otherwise you have one face of the planet facing the sun constantly and the other face not. And so, if we picture human life on our planet when we are tidally locked, tidally locked with the moon is a different thing, because then we'll turn once every 29 days, right? Unless we both slow down and then it becomes longer.
Yeah, I mean, everything will settle into an equilibrium. It may turn out, well, we're actually causing the moon to orbit a little faster because as Earth turns under the moon,
we give it some of our energy.
Earth's tidal bulge pulls away from the moon faster than the moon can travel, and so it actually gives it a pull forward. So the moon will actually, in the long far future, the moon will speed up in its orbit, cause it to move farther from the Earth, and the Earth will slow down in its spin, and eventually they'll settle in some point where the moon and the Earth are tidally locked, with the moon farther away than it is now. And I don't happen to remember the predicted. I think you could model the whole thing, but I don't happen to remember the distance that'll mean. I do know, though, that we'll never have total solar eclipses anymore.
Yeah, because the moon will be too far away.
Yeah.
Too bad.
They'll all be annular.
Oh, well, appreciate them while they last.
But well, you'll be able to get in a spacecraft and go see an eclipse. So that's okay.
That's fine. There will be space tourism by that point. All right, our last question from Robin, which I maybe shouldn't have saved till last because this is the one I understand the least. Why do astronomers continue to use the Julian calendar for dates that predate the Gregorian calendar? It introduces the drift that the Gregorian calendar corrected into astronomical dating. Why not just use the Gregorian calendar?
So, first of all, you've got Julian day that you can use here. So astronomers typically use Julian day. They don't use December, January, February. The real professional astronomers, they use Julian day, which are basically like star dates. They're basically day and decimal day, right? Mm-hmm. And that's meant to account for anything crazy that happens in our secular calendars. I don't remember if it's true, but it's possible that a software like Stellarium might, if you set the date to 1582, October 4th, 1582, it actually might fix that. It might take account of that jump. I don't remember if it does or not.
Yeah. I feel like the main reason we use the Julian calendar is so that nowadays anyway, so that we can divide the night easily into decimals, and therefore computers can keep track, because it's harder for automated telescopes to follow along when you're using an imperfect randomly sort of attributed time measurement like hours, minutes, and seconds.
Are you watching the screen? There's October 4th.
Now I will.
There's October 4th. There's October 15th.
Cool.
So Stellarium accounts
Those dates don't exist for Stellarium. That's cool. Super neat. Awesome. Okay, so that's all of our questions, I believe. Arnold Brody mentioned, who I believe is Toronto Center member, mentioned that Wikipedia says that the sun will go red giant and swallow the Earth before the moon and the Earth get tidally locked. So not to worry about the eventuality of that system, because the sun will swallow us first.
Oh, what a downer. What a down note, Arnold. I tried to find it. I did have the formula somewhere where it's time in years equals, and there are 4 or 5 parameters that you can plug in: massive Earth, massive moon, massive in orbit, and it'll actually calculate how many years before they become tidal locked.
That's cool.
Things like Pluto and Charon, it's already occurred.
Yeah.
All the large moons in the solar system are already tidally locked to their planets.
And Mercury is almost tidally locked with the sun.
Yeah.
Almost, but not quite. Its day lasts like 2 or 3 times its year or something like that. I think 2 times its year, something. So like its day, it's almost there. It's really, it turns really slowly, but it's not quite there yet. Alrighty, I think that's it. And on that note, I have yet again not prepared what we're doing next. There is a talk tomorrow night if anyone's interested. Tomorrow night we have the history committee presenting. Oh no, that's a lie. I lied. We don't.
The Toronto Center has a meeting,
The Toronto Center
streaming their
has a
meeting
meeting.
tomorrow night.
Yeah, that's the one. Toronto Center has a meeting tomorrow night. If anyone is interested, we have our next Insider's Guide session will be on the 30th of March, which is going to be about observing the Aurora Borealis, because it is a good season for observing the Northern Lights.
That's right.
And then we have on April 1st, we have our new series starting for observing the moon. That one's called The Moon at Noon. And if you're interested, you can check everything out on rask.ca/online to see what's coming up in the next little while. If you also want to, Chris noticed that there have been several rewatches of our series on YouTube. So you can always go back and check YouTube series that we've done in the past, or past episodes of Insider's Guide, which are all on youtube.com/c/RAS Canada. So our national.
Yeah, if you've joined us in progress, go back to the beginning. We did some really nice, basic, rewatchable ones at the beginning.
We did, yeah. And the beginning is as of the end of March, 1 whole year ago. So there's a lot of content out there.
Perfect.
Thank you, Chris, for sharing all of your knowledge. And we will see you all in a future episode.
Keep looking up.